51. Let's read it. Van der Waals constant A and B are related with critical pressure PC as. Student, I'm writing the correct formula that relates critical pressure and Van der Waals constant A and B. PC is equals to A upon 27 B square. That means correct formula is represented in option number 2. So here I'm writing correct answer is option number 2. Moving to next, which is question number 52. Let's read it. A gas is allowed to expand in an insulated container against a constant external pressure of 3 atm from an initial volume of 5 liter to final volume of 9 liter. The change in internal energy delta U of the gas is. Student, for this question, first of all, we'll be calculating work done. So work done is equals to minus P external delta V. We are given with P external and the change in volume. Initial is 5 liter and the final is 9 liter. So let's put the values. Minus 3, 9 minus 5, which is equals to minus 12 liter ATM. Since pressure is in atm here and the volume is in liter, but we have to convert this into joules, so we need to multiply the value by 101.3 and we'll get the value in joules. And student, I've already multiplied this will be minus 1.2 kilojoules. Now student, we have to calculate delta U, and as you all know that delta U is equals to Q plus W. In this question, we are given with insulated container. That means Q is equals to 0. So delta U is equals to W, which is equals to minus 1.2 kilojoules. So the correct answer is option number 1. Here I'm writing answer is option number 1. Moving to next question, which is question number 53. Let's read it. 1 mole of an ideal gas at 37 degree Celsius temperature undergoes expansion isothermally and reversibly from 5 liter to 20 liter. The entropy change in the process is. Students, for this question, we need to know the formula for entropy. I'm writing it, students. Delta S is equals to NR ln V final upon V initial. NR, let's convert into log. So 2.303 log V final upon V initial. Here we are given with 1 mole, that means the value of N is 1. The value of R, it will be 8.314 since we have to answer in joule. So multiplied by 2.303 log. V final is 20 liters and V initial is 5. So 20 upon 5. Student, you need to multiply all this and divide whatever the value is. I have already calculated and the value is 11.5 joule per mole per Kelvin. That means the correct answer is option number 1. Here I'm writing answer is option number 1. Moving to next question, which is question number 54. Let's read it. Which among the following is an intensive property? Students, intensive properties are those which are independent of the quantity of matter. Here pressure is an independent quantity, enthalpy is a dependent property, and density is also an independent property. That means both 1 and 3 are intensive properties. So the correct answer is option number 4. Moving to next question, which is question number 55. Let's read it. 100 ml of 0.3 molar HCl solution is reacted with 50 ml of 0.6 molar NaOH solution. The heat released in the neutralization process is. Students, for this question, first of all, we need to know that the heat released in the neutralization of 1 gram equivalent of a strong acid with 1 gram equivalent of a strong base is 57.1 kilojoules. So let's find out the amount of acid and base given here. So let's calculate millimoles of HCl first of all. So millimoles of HCl is equals to the volume given is 100 multiplied by the molarity, which is 0.3, which is 30 millimoles. Now let's calculate the millimoles of NaOH. So millimoles of NaOH is equals to 50 into zero point 0.6, which is again 30 millimoles. Now students, let's calculate the heat released. So heat evolved in the neutralization process will be 30. Now we'll be converting this into mole. So 10 to the power minus 3 multiplied by 57.1, which is equals to 1.7 kilojoules. That means the correct answer is option number 3. So here I'm writing option number 3. Moving to next question.